Hello everyone. So today we'll be solving this Leetcode medium problem, subsequence sum after capping elements. So I like this problem may be tagged as medium, but like it is pretty hard only. So let's see the problem statement. So we are given an integer array nums of size n, as well as we are given this positive integer k. Now an array capped by value x is obtained when we replace each element of this nums array with minimum of nums element of I comma x. Okay, now for each integer x from 1 to n, we need to determine whether it is possible to choose a subsequence from the array which is capped by this value x. So for each value from 1 to n, we'll keep this x as 1, then 2, then till n, and now we'll create a new capped array. Okay, and in that capped array, we need to see whether we can choose some of the elements from that capped array to get the sum as exactly k. Okay, and then we need to simply return a boolean array answer of size n, where answer of I will be true if it is possible to like make sum as means I plus 1, means since it will be 0 based. So if it is possible to make sum 1, means it is possible for x equals to 1 to get some k, then we'll return true, means answer of 0 will be true, and so on. Okay, so what means the summary of the problem statement is we are given an integer nums of size n and a target sum k. Now for each integer x from 1 to n, we need to construct a new array where every element v in nums becomes minimum of v comma x. Okay, and then we need to check whether there exists a subsequence in this new array such that the sums of those elements is exactly k. Okay, and then we need to simply return a boolean array. So, and also we can see like n can go up to 4000 and the elements of the array will be lying between 1 to n only. Okay, 1 to n. So let's try to like observe what will be the like the most naive way or the brute force way of solving. So before moving on to it, let's see the given input. So for example, we have n equals to 4. So we'll check for x equals to 1. For x equals to 1, the array will become, we'll take minimum of x comma each element at each step. So it will become simply 1, 1, 1, 1. Because minimum of 4 comma 1 is 1, minimum of 3 comma 1 is 1, and so on. Now in this element, we need to see whether we are able to choose some subsequence such that their sum is 5. And as we can know, like there will be no possible way of choosing elements such that their sum becomes 5. So this is not possible. For x equals to 1, it is false. So hence it is given as false. Now for let's see for x equals to 2. So the array will become, again all the elements are less than equals to 2. So the new array will become 2 to 2 only. Now again we see we will not be able to make sum 5 because like all elements are 2. So possible sums are 2, 4, 6 and 8 only. Okay, so for x equals to 2 also it will be false. Hence the output here is false. Now let's see for x equals to 3. So for x equals to 3 we have 4 comma 3 is 3, 3 comma 3 is 3. Now for minimum of 2 comma 3 will be 2 only and minimum of 4 comma 3 will be 3. Now we need to see whether we will be able to make sum 5. So we can see like if we choose this 2 and any of the 3's, so 2 plus 3 will become 5. Hence we will be able to choose any subsequence. Either we can choose this subsequence or this means this subsequence or this subsequence, right? So we can choose any of these subsequences and they have the sum as k. Since for this it is true. Now let's see for x equals to 4. So the nums array will become 4, 3, 2, 4. And again we can see like we have these two elements 3 plus 2 which is 5. So we'll be able to make the sum k equals to 5 and hence it is true for this. Then for each x from 1 to n, we need to calculate whether there exists any subsequence in the capped array whose sum is exactly k. Let's see another input. So we are given 1, 2, 3, 4, 5 and k equals to 3. So for x equals to 1, we'll have 1, 1, 1, 1, 1. And as you can see, we will be able to make k equals to 3 sum by choosing any of the 3 ones. So hence it is true. And similarly, like it will be true for most of the means for all the cases if we try to see the diagram. So like what will be the most naive way of solving it? We'll try to do what the question is asking us to do. It asks us to iterate through each means x from 1 to n. Okay, so what we'll do, we'll iterate for x from 1 to n. Okay, now what it asks us to do, it asks us to construct a new array where every element v in nums becomes minimum of v comma x. So it asks us to create a new capped nums where it is minimum of nums comma x for each element. Okay. Now once you have created this nums, we need to see whether there exists a subsequence in this modified means capped num such that their sums exactly k. So that means it is similar to the subset sum problem. So this is like a very popular problem of subset sum, which is means used solved using DP. So what we does is we need to means we'll simply create a 2D DP or a 1D DP. So we suppose we create this DP of index from a sum. So it will denote like if we pick the array from 0 till index, we see like whether getting sum equals to this sum dash is possible or not. Okay, so we try to do means we'll create this DP array and then we'll simply see for sum equals to k whether this is possible or not. Okay, for sum equals to k whether the DP of n minus 1 comma k is true or not. Okay, so we can use this, or we can use like a simple 1D DP as well, where DP of sum dash will denote whether means sum equals to sum dash is possible by picking some elements from the subsequence of the capped nums array. So means I will not be teaching you how we calculate this. We'll simply like follow the pick non-pick nature of this, and we'll simply like iterate through the entire element of index suppose capped nums, and now we need to move from k because the maximum value that we'll be creating is k. So initially we'll mark the DP as we'll create a DP of k plus 1 and mark it as false initially, and initially DP of 0 only will be true. Okay, because 0 sum is always possible for empty subsequences. And now we'll simply start from int sum equals to k and sum greater than equals to this x, because the current x that we have is this, and we'll decrease this, and now we'll see like if we are able to get means DP of means if this DP of sum minus k is true, then that means we'll be able to use this x to make the DP of sum as well as true. So we'll be able to make DP of sum equals to true as well. So we'll keep doing this, and at the end we'll simply check like if DP of k is true, DP of k is equals to true. So we'll have the result vector of size n, okay, which will denote the result for x equals to 1 till n, and we'll simply like mark x result of x minus 1 since x moves from 1 to n. So to make it 0 index, we'll simply mark it as true or false. So if it will be simply equals to DP of k only. So if it is equal or not equal, it will be simply equals to DP of k. As you can see, like the approach here would be to iterate for x from 1 to n, so which will take us big of n here, and we see like the internal check for the subset sum problem. This is solved in big of n into k. Okay, because the time complexity of this is n into k, and here either we can use n into k space or we can use simply big of k space. Okay, so both are fine. So the overall complexity will become n into k, which will be n square into k, and we see like n and k can both go up to 4000. So here it will be what, it will be 64 into 1e12 1e9. So this will be obviously of the order of 1e10, which will give us TLE here. So let's try to see the solution as well for this brute force approach, so that this means you are able to recall the subset sum problem as well. So let's see this means brute force solution. So we create this bool result, which will be storing the final result of for each x from 1 to n. Now we iterate for x from 1 to n. We create this capped nums, which is simply minimum of num comma x for each element from nums, or each element of nums. Now we need to solve this subset sum problem for this specific capped array. So we'll create a DP of j will be true if sum j is possible. So we create, since sum can go, we only need sum to go from 0 till k. So hence we'll create a DP vector of size k plus 1, and initially DP of 0 will be true. Now we iterate through the capped nums array. and then we simply, like, if the dp of j minus val is possible, then that means we will be able to use this val to make dp of j as true as well. And now we'll simply mark the result of x minus 1 as dp of k. So if we are not able to get, means if some k is not possible, then it will be false, else it will be true. And this will be the big of n square into k algorithm for this problem. So I hope like you are able to, means you know how we solve this subset sum. And if you don't, like, this will be very simple. Either we can use memorization or the tabulation or this space optimization version as well. I use this so that, like, it is, means is smaller to see, and like since it is the brute force, that's why we are not deep diving into it much. Now how we like optimize from this n square k to something of the order of, as you can see, like both n and k are up to $4,000. So we simply, like, if we, n square will be 1e6, 16 into 1e6, so approximately 1e7. So we may think like something, we need to think of some solution which runs in this complexity, right? N into k. So either it will be like n square or like big of n into k. We need to think of this, means an approach which runs in this complexity. Now what, like what is the redundant thing that we are doing here? So at each step, what you are doing means this x will definitely need to traverse from x for 1 to n, right? This we cannot avoid, but we are saying like to update these dp values, we are, means creating this dp vector every time, and then we need to move through the entire capped nums array every time, right? So maybe we can try avoiding it and create a dp which maintains like a running, means running values of whether dp of s is possible or not. So maybe like either we can try to avoid this loop or try to avoid this loop, and as well as we'll try to move this dp out so that we do not need to calculate these values in big of n into k. Maybe do something so that we are able to calculate it in big of n or big of k. Okay, so let's try to observe, like based on the this minimum condition that we are given, let's try to observe what means observations can we make here, and then we'll try to solve the problem. So we are given that a capped nums array will be simply what, minimum of nums comma x, right? Hence if, means for each element, suppose this is the element, so if element is less than equals to x, that means it will, means in the capped array as well it will remain element only, right? But if this element is greater than x, then it becomes x. Okay, so suppose if we like sort the nums array so that we, means get all the less than equals to elements in on the left side and all the elements which are greater than x on the right side. So suppose we are given this nums array. Now we have the indexes, suppose 0 till j. These all elements are less than equals to x, and from j plus 1 till n minus 1 we have all the elements as greater than x. So hence if this was the nums array, then the capped nums array will become like, we'll have these elements will remain the same only, means it will remain the 0 till j, these part will remain the same, and for these part all the elements will become x x x x x, right? All the elements will become x and this will remain the same. So what do we observe here? If you like, try for a given x, as we like will be moving x from 1 to n, right? So this x, if is what it's, if it was, means it will start from 1, so the number of values greater than x will be very large initially, right? Means there will be a case where all the elements are greater than x, since like we know like the nums value of nums is from 1 till n, so initially all the values will be greater than equals to x either, so means the entire array will become x x x only, right, for x equals to 1. Okay, now when x equals to 2, maybe some of the elements will remain the same and the remaining elements become x. Then x equals to 3, maybe some more elements will remain the same and the remaining elements will become x, right? So as soon as we, means keep increasing this value of x, there will be more segment which will remain the same, and there will be a lesser part of the segment which will be which will keep the same as x only. Okay. So what can we observe here? So what do we want? We want means for each x, means for each of these arrays that we have, we want to see whether k sum is possible or not. Okay, possible or not. So we know that there are two parts in which nums will be divided, from 0 till j, and then the part where all elements are x. So this is same and this is x. So means if we want to make sum as k, sum equals to k, now this sum will have some elements from this segment, right, which is the same as nums array, and we'll be using some number of x's here, right, because from j plus 1 till n minus 1 we have all the elements as x. So we'll be definitely using some of the x's here, and then some of the elements from the nums array, which will be just simply means which will be the same whether we count it as cap or whether we see it in normal nums array. Okay, so what can we do here? So we see like this sum will be, suppose, this s1 plus s2. Now this s1 will be simply what? It will be from nums of 0 till j. Okay, and this s2 will be some number of x's, because all the elements are same. So whether we'll pick 1x or 2x's, so x plus x, or we'll pick 3x's, so x plus x. So let's say it is simply m into x, means we have picked m elements from this segment, and then the remaining sum that we need, that is k minus m into x. We try to make this sum from this nums array initially. Okay, so now we can try to see that this is this is giving us the idea to only calculate the dp values from the original nums array only, right? We do not need to update the nums array to create a new capped nums array, because what the problem was, we are creating in the brute force, we are creating this capped nums array and then creating a new dp and then seeing whether it is possible for this, means for this new capped array in n into k, means we are recalculating every time. But here we see that we just need to maintain, means this m can vary. Now how much this m can go? So either we'll picking 0 axis or 1 axis or 2 axis till so on, such that we have, means we'll simply see the number of, means it will be less than equals to frequency of x, and frequency of x is simply number of elements greater than equals to x in nums. Okay, so we'll be moving m these many number of times, right, from 0 till frequency of x. Now for each m, means m will move in this manner. So for each m we need to see, means the remaining sum will be what? K minus m into x, right? So now we need to see whether till this, means till the elements that we have used so far, means the elements that are x, so the elements which will keep remain the same. So we need to see whether dp of this rem is true or not. Okay, is true or not, right? Now how will, means keep updating this dp? So instead of recalculating this dp every time, because in brute force we recalculated this dp at every step, but what did we observe initially? We initially observed that initially the segment that remained the same was very small, then the segment that means remain the same increases, then it again increases, and it will keep on increasing only. Hence as soon as we move x, means x increases, the segment that remains same, that also increases. That means we'll get a new element which is part of first segment, right? Part of first segment. So hence what if we, means calculate a running DP. Means instead of declaring this DP inside, we declare this DP outside only and maintain a running DP of the means based on the x will have the left segment from 0 till j and will have the right segment which will have all x's. So this means some element will be getting newer because initially this j would have lied, means this segment would have been smaller. So we'd have got some new elements, right? Some new elements. And what will be new elements? So for x minus 1, this was the case. And now for x, we are getting this. So the x that we previously used will be the new element that we'll be using in this case, which will be a new element. Okay. So number of times it is present in this frequency array, in this nums array, that many times we can use this new nums, right? So maybe based on the number of times this new element that we have, that we used previously, maybe based on its frequency, we'll be able to update this DPL. Okay. So instead of like recreating the DP each and every time for each axis, we try to see that suppose x was 2 initially, okay, and nums was, we had 1 1, then 2 2 2, okay. Now when x becomes 3, 2 2 2 3 4, okay, suppose this is it. Now when x becomes 3, we knew that means the previous x that we used, these values will be remaining the same, because for x equals to 3, these values will be less than 3, right? So hence these values will remain the same only. So hence the new means initially for this x equals to 2, this entire part would have become 2 2 2 2 2 2, right? And this had remained the same. But for the new, the segment will become 2 2 2 2. So the left segment will increase to this and the right segment will become 3 3, right? Hence the number of times this 2 was existing in nums array, means the number of times here 4 times. So we'll be able to use this 2 4 times. This will be able to use this 2 4 times. So if we initially had the DP of size k plus 1 and we had like it has calculated for each sum, DP of sum means denotes whether sum is possible or not, okay. Suppose DP of j, so it means whether some j is possible or not, okay. So we see like when we'll be using this new element, so what do we need to do for this newer x? Will before moving on to this newer x, in the end we can simply like update the DP for the next step. Means if this was the x initially, x equals to 2, once we have calculated the result for this DP, we'll need to update the DP values for further x's. So we'll see like if means we initially calculate the frequencies of each element in the x. So if this frequency of x is greater than 0, then that means we'll be able to use int count equals to frequency of x. So we'll be able to use this x in our means calculating some values, count number of times, okay. And what do we like needed to calculate initially? We were moving for m from 0 till less than equals to frequency of x, the new x that we had, okay. So in the end we'll simply need to check whether the DP of this remaining is true or not, okay. So hence we simply update this DP in current step by moving this count many times. So for we'll move this as from count number of times. So either we'll use c equals to 0 till c less than count, okay. These many times we'll be using it. And now it c equals to 1 till c less than equals to count. And now we'll see, means if we'll use it, then we simply use the same phenomena that we used in normal DP tabulation. That was we'll move from j equals to k till j greater than equals to 12, and so we'll move from j equals to k till j greater than equals to x here and j minus minus. Now we'll see like we'll simply what do? We'll see DP of j will become true if either it is already true or the DP of j minus x is true, okay. So if it is j minus x is true, that means we'll be able to add this element x and this DP of j will also become true, okay. So the same that we did in brute force, the same thing we'll be doing here as well. So I hope like you are able to see how we means instead of recreating the DP every time, based on the new element that we are getting, based on this new element that we are getting, we calculated this recalculated instead of recalculation, we just simply updated this DP. Now you might wonder that this count you are going till means count many times and then this is going till x. So maybe this is n cross k in each step. But no, we see like this count is basically frequency of x. So the total number of times means suppose we have the element as 1, 1, then 2, 2, 2, then 3, 3. So the first time this loop will run 2 times, then the second time it will run 3 times, and the third time this loop will run 2 times. Okay, so overall this particular loop will run n times only. Okay, so in each iteration we will not be running it n into k, because overall this loop will run n times and this will run k times. So the overall complexity will still remain big of n into k. Even if we have the x loop from 1 to n, this loop will in means overall fashion will only run n times, so hence we'll be getting k into n only. Okay, so I hope you are able to like follow how we'll be using these means x as well as m, and how we on the basis of number of elements that we'll be using from the right segment, we try to analyze means calculate the running dp for the elements that remain the same. Let's try to see the code so that this approach becomes clearer once we see the approach. So what do we do initially? We create this frequency so that when we move from x till x plus 1, we already know the number of times we can use this x for x plus 1, which will remain the same, because x plus 1 it will remain the same, and this x will have means it will lie in the range from 0 to j, which remains the same only. Okay, so this x, as we move from x to x plus 1, we'll be able to, based on the frequency of x, we need to be able to update the dp, hence we initially calculate this frequency only. Okay, now we create this dp, instead of recreating it inside this, we create this outside only. Now dp of j will be true if some j is achievable using elements less than x, because we'll be using m elements m into x, and we'll be using some elements s dash from such that their sum is s dash, and s dash plus m into x is equals to k. So we just need to check whether the sum that we are getting from this is true or not. Then we'll simply for k minus mx, we'll check, and if it is true, then we'll simply update our result with true. So we'll care. Now this result is a boolean function which will be either false or true. Okay, for each x from 1 to n. Now initially we also need to know like the number of elements that we have currently which are greater than or equals to x. Then only we will be moving m from like 0 till this frequency of x. Right? So it will be simply the number of elements greater than or equals to x. Okay, so it will be, because number of elements greater than or equals to x is frequency of x, because all the number of elements which are greater than or equals to x will become x only. That's why we have simply used this elements greater than or equals to x. Now we move x from 1 to n, we move m from 0 till m less than or equals to elements greater than or equals to x, and we also need to make sure that the requirement that we have does not become negative, right? So this means k should be greater than or equals to m into x, right? Then only the requirement does not become negative. So we also do this check and increase m. Now we see like if this requirement is already true, then that means we'll be able to satisfy the requirement for our current x, and hence we'll mark this possible variable as true and we'll simply break. And that means if we are able to make it possible as true, then it will become true, as well, else it will remain false only. Now we are moving, means we'll be increasing this x in the next step. So we need to update this dp value, right? For the next x, we need to update this dp value, because the number of elements which are less than x will be increased. This 0 to j segment will be increased for the next segment. So the number of elements, this frequency means the number of elements this x was present in the original nums, will be able to use this to make this sum s dash. Okay, and this m into x will change, because the number of elements greater than or equals to x will also change. So what do we see? If this frequency of x is greater than 0, then we see like the count that we have is frequency of x. So we simply move from like count number of times, and we use the same logic of dp updation. that move j equals to k till j equals greater than equals to x, it is simply x, and we'll update it if dp of j minus weight is true, then we'll say like dp of j will also become true. And else, and when we move from x equals to x plus 1, the number of elements greater than equals to x will be decreasing by a factor of the frequency of x. Okay, so that we only account the number of elements greater than equals to x plus 1 in the next step. So in this manner, we will be able to calculate, means we will finally return the result. So in this manner, we will be able to calculate the TP values in a running fashion as well as update this result vector that we had. So like you can see, like this is not a medium problem. It is like pretty hard if we try to think about how we'll try to calculate this running DP. My thinking about this brute force solution was very simple, but how to means transition from this brute force and how to move this DP array out of this loop was the main concern here. And once we tried to think in that direction, we saw that this nums can be divided into two sections. The elements which are less than x and elements which are greater than equals to x will all become x only. So hence we'll be picking some number of x's from those and some from this side. So if we pick some number of x's, so we try to simulate the number of x's that we'll be picking from the right side. And hence will means once we try to simulate that experience, means the number of elements that we'll be picking from the right segment, then we'll simply the remaining sum required will be k minus mx, and that we means the whether that sum is possible or not, we try to create, means we'll try to store it in this running DP only. So this was the overall approach for this problem, and as you can see, like the overall complexity is, and means this runs in big of n and this runs in big of k. So this is n into k, and you might also think like we are again running big of k and big of n here. So again this is like n into k into n, but it is not, because this big of n will only runs, means it will run a total of big of n number of times, because it is going till frequency of each number from nums array. Okay, so this will run overall big of n times, hence the overall complexity will be big of n into k only, which will be possible, which will be like accepted, because we had what we had 4000, so it will be of the order of 1e7 only, which will be acceptable in 1 second limit. So like this was the overall approach for this problem. Let's try to submit the code as well. So let's try to submit the normal code first. This is the means accepted code. Let's try to submit it, and then we'll be submitting the TLE code and see like how many test cases. So this runs fine. This was the optimized approach that we discussed, and let's try to see the TLE approach. So this was the TLE approach. It okay, as we have submitted it, we see like it is taking a lot of time to run, and we'll see that it gives TLE on 745 days case because of the n into k loop inside. So this was like the overall approach for this problem. I hope you were able to follow along with the approaches, how we like try to transition from the brute force to optimal one, and that is what we generally tend to do. Means transition from the brute force and take learnings from the brute force solution, because we took learning of this into the same in our normal solution as well. So this thing remains the same only. So yeah, writing means the brute force solution sometimes may help you to guide towards the optimal one. So yeah, if you are able to follow along with all the approaches, make sure to like as well as subscribe, and if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.